Right, in this video, we're going to talk about suggested homework problems from 5.7. Our topic of discussion is inverse trigonometric functions. We're going to talk about differentiation of them, and we're going to start with a little review of inverse trigonometric functions from pre-calculus. Hopefully you had an introduction to those in pre-calc. They're going to be important in calculus, as we'll see that there's some forms of integrals that give us answers of inverse trig functions here. So important things to remember about inverse trig functions are that they return angles usually in radians. So three of them return angles that are between negative pi over 2 and pi over 2. Quadrants 1 and 4 to 1 to give us negative angles are going to be in quadrant 4, and positive angles are going to be in quadrant 1. These would be the arcsine function, the arctangent function, and the arccosecant function will return angles in quadrants 1 or quadrants 4. The other three return angles in quadrants 1 or quadrant 2. So those angle measurements are going to stay between 0 and pi. They'll always be positive values. And that would be arccosine, arccotangent, since it has a cosine in the top of it. And the reciprocal of cosine is secant, so arccosecant. So make note of that. That's going to be important here when we look at these. So when we have arcsine of 1/2, which this book prefers to the inverse notation that you may know, like this, simply because that doesn't get confused with reciprocal functions. We want to be clear that we mean the inverse sign, the arcsine. So we'll spell it out like that in this book typically, though I may accidentally write it the other way because that's the way that it appears on the calculator there as the second functions of sine, cosine, and tangent. Where on the unit circle do we have a sine value of 1/2 in the region of negative pi over 2 to pi over 2? So I'm going to have a positive sine value. I'm in quadrant 1. I'll draw my triangle here for you just to show you what we're saying. That sine value is 1/2. I'll make this side √3. If I know my special right triangles, this is obviously a 30-degree angle here, since this is the 30, 60, 90, but I need my answer to be in radians, so 30 degrees is pi over 6. Number 9, arc cosine of 1/2. So cosine is 1/2. Very similar triangle, but a little different. We have theta, have 1, we have 2. So now this is the 30-degree angle. So this is the 60-degree angle. So that's pi over 3. Let's look now at number 11. 11 says arctangent of √3 over 3, or arctangent of 1 over √3 would be equivalent. So that's a positive value. I'm in quadrant 1. Tangent is opposite over hypotenuse. So I have a 30, 60, 90 right triangle. My theta there that has that tangent value is going to be pi over 6. So erase these, move on to number 13. Number 13 says arc cosecant of -√2. Well, I don't really have cosecant values memorized. I have sine values memorized though. So I will take the arc sine of the reciprocal of the inside, -1/√2. And sine has a negative value, so that's going to stick it in quadrant 4. It's going to be a negative angle to me. And I want this to be a -1, this to be square root of 2. This will give this +1, but that's going to be -45 degrees or negative pi over 4 when I look at my reference triangle there. That's a 45, 45, 90 reference triangle. Now, let's use our calculator for the next few here. There's only going to be one answer to these when I put them in my calculator. So second arc cosine like that of 0.051, and make sure that you are in radian mode here. You don't want answers back in degrees for this. It says round your answer to 2 decimal places. It's assumed that you are dealing in radians here. So 15 is 1.52 when we round to 2 decimal places. 17. I need a little bit of work for that. So arc secant of 1.269. I don't have an arc secant button on my calculator. What I do have though is arc cosine, and I can find the reciprocal of 1.269 by putting it over 1. So arc cosine of 1 over 1.269, rounding to the nearest hundredth, is approximately 0.66. Let's look now at number 25. We want to evaluate expressions, and we'll be drawing triangles to help ourselves evaluate the expressions. So first, we want the sine of the arc tangent of 3/4. So tangent is positive. I'm in quadrant 1. 3/4, so opposite over adjacent. I know that this is a 3, 4, 5 right triangle. Use the Pythagorean theorem if you need to prove to yourself that that's 5. But hopefully you know 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17 triangles, so you can just use those in these problems. So this is sine of the theta that I just defined with this triangle. So sine of theta is 3/5. Let's look at part B. It says secant of arc sine of 4/5. So again, quadrant 1. And we have sine value is 4/5. So this is again is a 3, 4, 5 triangle. This is secant of theta, which is, remember, that's hypotenuse over opposite. So hypotenuse over adjacent. Hypotenuse over adjacent. This is the reciprocal of cosine. So that is hypotenuse over adjacent, 5/3. Let's look at 27. Part A, cotangent of the arc sine of 1/2, sorry, of -1/2. So we are, arc sine is -1/2. There's my theta down there. Cotangent of theta, that's defined by that. Cotangent is adjacent over opposite. It's a -√3. Part B, cosecant of the arc tangent of -5/12. So we're down in quadrant 4 again. -5/12 for the tangent value. And this is a 5, 12, 13 right triangle. So this is cosecant of theta, which is 1/sine theta. That's going to be hypotenuse over opposite, is 13/-5, or -13/5. Number 29. Going to use these triangles to simplify expressions down into algebraic expressions. So cosine of the arc sine of 2x. So assuming that the triangle is in quadrant 1, always, we're going to say sine is 2x over 1. And then we have the other side will be the square root of hypotenuse squared minus side squared. We'll call this theta. So cosine of theta is √1 minus 4x squared over hypotenuse of 1. So that's √1 minus 4x squared. So this complicated expression simplified down into that simpler algebraic expression. If you want to see how I got this here, remember that this unknown here, call it a squared plus 2x squared is equal to 1 squared. A squared plus 4x squared is equal to 1. A squared is 1 minus 4x squared. And because a is going to the right, I need the positive square root, 1 minus 4x squared. I just used the Pythagorean theorem to find it. 33 is tangent of arc secant of x over 3. So I'm going to change that up a little bit since I don't like secants. I'm going to call this arc cosine of 3 over x. Draw it in quadrant 1. So cosine is adjacent over hypotenuse, and this is hypotenuse squared minus side squared for that other side. And so tangent of theta is going to be opposite over adjacent. Let's look at 41. And we'll start finding derivatives. So we have a few derivative functions here. Let's define those. Arc sine of u is equal to u prime over root 1 minus u squared. Arc cosine of u is exactly the same thing, but it's negative. Arc tangent of u is u prime over 1 plus u squared. Arc cotangent of u, same thing but negative. Arc secant of u is, let's see if they did an arc secant problem. They didn't, but it is over absolute value of u root u squared minus 1, and I think that's right. Some books have the absolute value inside of the secant. Some have them down here. I'll do it down here because secant values can be negative for sure. So I'll put it down there. So arc cosecant of u is same thing but negative. Like that. And let's go ahead and let's use those now to solve some problems. So starting with number 41. F of x is arc sine x minus 1. So u is equal to x minus 1. U prime is equal to 1. F prime of f of x is equal to arc sine of u, meaning f prime of x is u prime over root 1 minus u squared. It's 1 over root 1 minus x minus 1 quantity squared. And they don't want you to leave it like that. They want you to expand that. Minus x squared minus 2x plus 1 is 1 over root 1 minus x squared plus 2x minus 1. 1 minus 1 is 0. And f prime of x is 1 over, they want you to write the subtraction as 2x minus x squared. So let's look now at number 43. G of x is 3 arc cosine of x over 2. So u equal to x over 2 and u prime equal to 1/2. G of x is equal to 3 arc cosine of u. G prime of x is 3 times, then the arc cosine function is negative u prime over root 1 minus u squared. So g prime of x is a negative 3 times 1/2 over root 1 minus x over 2 quantity squared. Negative 3/2 over root 1 minus x squared over 4. I don't like leaving fractions inside of roots, so I'm going to make a common denominator and fix that square root there. I'll leave the numerator alone until I see what the denominator does for me. So this is 4 minus x squared over the square root of 4 is negative 3 halves over root 4 minus x squared over 2. So g prime of x is negative 3 over 2 times 2 over root 4 minus x squared is a negative 3 over root 4 minus x squared. So now at number 45. 45 is f of x is equal to arc tangent of e to the x. So u is equal to e to the x, and u prime is equal to e to the x. F of x is arc tangent of u. So f prime of x is u prime over 1 plus u squared is going to be e to the x over 1 plus e to the x squared is e to the 2x. Let's look at 47 now. (47) is g of x is equal to arc sine of 3x over x, which is a u over v situation where u is equal to arc sine of 3x. V is equal to x. U prime is the derivative of the expression on the inside, square root of 1 minus that expression on the inside. So this is 3 over root 1 minus 9x squared. And v prime is 1. G prime of x is u prime v minus v prime u all over v squared. G prime of x is 3 over root 1 minus 9x squared times x minus 1 times arc sine of 3x all over v squared. So I don't like that denominator there. I'm going to multiply to get rid of it. G prime of x is 3x minus root 1 minus 9x squared arc sine of 3x over x squared root 1 minus 9x squared. I'll just add parentheses to be clear there. All right. Now at number 49. (49) says h of t is equal to sine of arc cotangent of t. I have two options here. I can simplify this with my triangle like we learned earlier, or I can just jump straight in and do the differentiation. I'm going to try the triangle method first just because they taught it to me in this section, so I figure they want me to use it. So cotangent is adjacent over opposite, so adjacent over opposite. That makes this side t squared plus 1. So h of t is the sine of theta. So h prime of t is going to be I can't do d theta. So h of t is, yeah, I can. Say h prime of t is cosine of theta, right? So cosine of theta is t over root t squared plus 1. Did I miss something? Arc cosine so let's look at it algebraically. 1 over oh, that's cosine. That's not good. Cosine, not cotangent. That's what's wrong. Cosine of t. That changes everything. So if cosine is t, then this is 1 minus t squared. That's where 1 minus t squared was coming from. So then I have sine of theta, and h of t is root 1 minus t squared here. And this is 1 minus t squared to the 1/2 power. H prime of t is equal to a 1/2 1 minus t squared to the negative 1/2 times the derivative of the inside is a negative 2t. 2 and 2 will cancel. H prime of t is a negative t over root 1 minus t squared. Right. So um, 51. No, 50, yeah, 51. Y is equal to 2x arc cosine of x minus 2 root, I'm going to give myself the entire board for this. So arc cosine of x minus 2 root 1 minus x squared. So we have u times v minus derivative of, I'll get to that in a minute, where u is equal to 2x, v is equal to arc cosine of x, u prime is 2, v prime is a negative 1 over root 1 minus x squared. So y prime is equal to u prime v minus v prime u all over v squared. No, this is plus because it's product rule. Yes, so I should just write that here. U prime v plus v prime u minus derivative with respect to x of, I should say minus 2 derivative with respect to x of root 1 minus x squared So y prime is u prime v plus v prime u minus 2, and then derivative of this is power rule. So 1/2 root 1 minus x squared times a negative 2x. So this is y prime is 2 arc cosine of x minus 2x over root 1 minus x squared. Negative negative is positive 2x over root 1 minus x squared. Those pieces zero out, and y prime is 2 arc cosine of x. Let's look at 52. Very similar problem where they give you an extra piece that's going to help zero out something from the product rule here. So y is equal to u times v minus 1/4 ln of 1 plus 4x squared. Y prime is u prime v plus v prime u minus 1/4 derivative with respect to x of 1 plus 4x squared. U is x and v is arc tangent of 2x. U prime is 1 and v prime is 2 over root 1, no, not root, no square root in arctangent 1 plus 4x squared in the denominator. So y prime is arctangent of 2x plus 2x over 1 plus 4x squared minus 1/4 times 1, this is ln, 1 plus 4x squared times the derivative of the inside is 8x. 4 goes into 8 2 times. So y prime is arctangent of 2x plus 2x over 1 plus 4x squared minus 2x over 1 plus 4x squared. These pieces zero out, and y prime is arctangent of 2x. Let's look now at number 56. And this will wrap everything up for this section. So 56 says y is equal to arctangent of x plus x over 1 plus x squared. So we have y is equal to the derivative, y is equal to arctan of x plus, I'll call that u over v. U is equal to x and v is equal to 1 plus x squared. U prime is 1, v prime is 2x. Y prime is arctangent is 1 plus x squared here. It's u prime v minus v prime u all over v squared. Y prime is 1 over 1 plus x squared plus 1 plus x squared minus 2x squared over 1 plus x squared quantity squared. So let's make a common denominator here. Y prime is 1 plus x squared squared, 1 plus x squared plus 1 minus x squared. going to be 2 over 1 plus x squared quantity squared. All right, that's it for this video, for this section. We'll come back next time and talk about 5.9, which will wrap up our discussion of Chapter 5 for Calculus 1. So see you for the next video.